So we'll start our discussion with complex numbers. I believe you have got some ideas of what complex number is. So whenever we're talking about complex numbers, what we need to understand is that we're talking about two things. We're talking about the real part and the imaginary part. So let's take, for instance, we have a plus bi. So in this case, this a is a real part, okay? Then bi is just basically the imaginary part. Okay, so as long as we have got two things, we have got a plus bi. The part which is having I is the imaginary part, and then the part which doesn't have I, that is the real part. Okay, that is the reason why if you punch on your calculator the square root of -4, you're going to get math error, but in actual sense this is going to be 2i, meaning it is imaginary number, it is not a real number. Okay, so now let's take, for instance, we have let's say we have 2xi plus 4y. Then I ask you to say, tell me the real part and the imaginary part. So what is the imaginary part in this case, and what is the real number? Okay, okay, thank you. What if we have something different? Let's say we have let me just put 2 plus 5i. The real part and the imaginary part. What is our real part? Okay, okay, are we following? So this is the basic idea behind complex numbers. Whenever we're talking about complex numbers, we're going to be dealing with two things. We're going to be dealing with the real part and the imaginary part. Okay, so now what if I give you this? What would you say? Let's say we have just 2. So what is our imaginary part and what is our real part? Come on. Any volunteer who would like to help us? We only have 2. So what is the real part and what is the imaginary part in this case? Gracious, you're most welcome. Uh-huh. Ha. Yes, yes. Yes, Naomi. Mm-hmm. Exactly. So if I write 2 plus 0i is the same as just 2. Okay? So meaning that in this case, the real part is 2 and the imaginary part is 0. That is the reason why it's not even there. Okay? Okay. Now, apart from that, I think the important thing again which you have to know is since we are talking about I, we are saying I is the imaginary part, the imaginary number, which is as long as you see I, meaning that is the imaginary part. Okay, so I said earlier on, I said if I have the square root over 4, it is 2. Then the square root of -4, it is just basically 2i. Why is it 2i? Because this is imaginary number, this is not a real number. There is no square root of -4. If you punch using the calculator, it's going to give you math error. So in short, it is undefined. So we're going to assume that it is imaginary. So that's the reason why we're going to say that the square root of negative 4 is going to be 2i. You get my point, right? Yes. So now, I think you have come across this. You have you have I squared, you have I to the power 3, and then you have I to the power 4. Okay, so what is I? What is I? Come on, come on, come on, come on, come on. What is I? You know these things, guys. Yes? I is 1. No, I is not 1. Yes, now. Okay, cool. Um, yes, Mwape. What is I? Yes, it's a square root of negative 1. Remember, guys, we said if I have got the square root of negative 4, this is a 2i. Meaning that the moment when I have the square root of negative 1, this is supposed to be I, not so. In short, the square root of 1 is 1. So negative I is going to be 1i, which is just basically I. Okay? So I is just basically the square root of what? Negative 1. Okay? What of I squared? Yes, Ruthie? Negative 1. What of I to the power 3? Yes, Naomi. Yes, Naomi. What is I to the power 3? Negative I. Okay. What of I to the power 4? Blessing Sakara is making a lot of noise. Blessing Sakara, can you please mute your mic? I'm trying to mute her mic. Okay. So you were telling me that I to the power 4 is what? Hmm? Come on, guys. Positive 1. So now, if you think of this, what is happening here is simple. As long as you know that I to the power 2 is negative 1, meaning that I to the power 3, if I have I to the power 3, this is the same as I to the power 2 times I. So you know that I to the power 2 is negative 1. Okay? Then I is just basically what? It's the same as we say I, because it's the same even if we say it is negative 1, but it's the same as I. So this is going to give us negative I. Now, if you say I to the power 4, this is I squared times I squared. So we're going to have negative 1 times negative 1, which is going to give us positive 1. So even if I give you I to the power 5, I to the power 6, I to the power 9, it's the same, right? Okay, so if you know this, then it's going to be very much easy for us to solve now questions. Let's say we have I to the power 12. What do you think this is going to be? What is I to the power 12? Yes, gracious. What is I to the power 12? I remember in 2021 there was a question, quiz 1. They said simplify I to the power 12. Mhm. Which is going, okay, gracious is saying this is going to be negative 1. Okay, okay. We also have some views from other people. What are we saying, guys? Yes, Mwape, what are you saying? What is I to the power 12? You are saying is I to the power 4 times I to the power 4 times again I to the power 4. So, sir, if you say I to the power 4 times I to the power 4, do, exactly. So we have this now. So we know that we said I to the power 4 is 1, not so? Positive 1. So meaning that we're going to have positive 1, positive 1, positive 1. So 1 times 1 times 1, we're going to get a positive 1. So I to the power 12 is positive 1 and not negative. It's making sense, right? Gracious. At the same time, you may think of I to the power 2 times I to the... You can raise I to the power 2 6 times. And you end up getting negative, negative. Now, those negative are going to be cancelled out. You understand, right? We continue. We continue. Okay. So how do we add? Yes, yes, please. Yes, you can do that. But again, if you do I to the power 3, because I to the power 3 is negative I, but we're trying to simplify, we're trying to come up with a number. So if we do I to the power 3, meaning it's going to be impossible for us to come up with the real part now. You understand, right? That's the reason why we have used I to the power 4. Because if I use I to the power 3, I know that I to the power 3 is negative I. And negative I is the square root of negative 1. Yes. Okay. Now, how do we add complex numbers? Let's say, yes, please. Okay, so if you are dealing with the same base, the powers are the same, we add the powers. For example, if we say 2 to the power x times 2 to the power y, this is the same as 2, then x plus y. Did you do, what's this? This is indices. So if I say I, yes, yes, if I say I to the power 4 times I to the power 4 times I to the power 4, meaning that this is the same as I add the powers. Okay, so it's going to be I 4 plus 4 plus 4, which is going to be 12. So it's going to be I to the power 12. So if you get it, okay, perfect. Now, how do we tend to add the complex numbers? Okay, so let's say we have 6 plus 2i, and then I have plus 3 and then plus 7i. How can we add these complex numbers? Remember, you cannot add a complex number and an imaginary number. Okay, the real part is supposed to go with the real part, the imaginary number is supposed to go with the imaginary number. Does that make sense? So for example here, what we're going to do here, we're going just to open the brackets. It's going to be 6 plus 2i plus 3 plus 7i. Now I need to get the real part on its own and the imaginary part on its own, and then I add them. So what I'm going to have, guys, is 6 plus 3 plus 2i plus 7i. Then what I'm going to end up having here is going to be 9 plus 9i, meaning this is my final answer. Any question there? Any question? Okay, since you don't have questions, let me give you another example. Let's say we have 8. Let me have 8 here, then let me put 2i, and then I put minus, I put a 12 plus 5i. Okay, now if I'm trying to open the brackets, remember that this negative is going to affect almost everything inside there. So what we are going to end up having is going to be 8 plus 2i minus 12 plus, minus again 5i. Is that okay? Then I'm going to have 8 minus 12 plus 2i minus 5i. So this is going to give me negative 4 minus 3i. I don't know if you're confused there. Let me know if you're confused. Are we all moving at the same pace? Hello? Mwape? Okay. Okay, so I'll give you one question. You have to submit this one after the class. So I'm going to give you 7. 7i plus 8. And then I put negative 3 plus 8i. So give me the answer in the group after the class. This one. So we go on how do we tend to multiply the complex numbers. Okay, so from there, now let's say we have 3 minus 5i, then we also have 2 plus 6i. So we know that this is going to be the same as 3 open brackets 2 plus 6i minus 5i, then 2 plus 6i. So I'm going to say that 3 times 2 is going to be 6, plus 3 times 6 is going to be 18i, then minus, this is going to give me 10i, then this is going to give me minus 30i squared. Remember we said I squared is equal to negative 1. So where we see I squared, we need to simplify this. Where we see I squared, we can replace it with what? Negative 1. So this is going to be 6 plus 18 minus 10 is going to give us 8i. Okay, what else are we going to have? We are going to have minus 30, then this is going to be negative 1. So it's going to be 6 plus 8i minus, so negative and negative is going to give us plus 30 now. So it's going to be 30 plus 6 is going to be 36 plus 8i. Meaning that from here we can see that 36 is the real part, 8i is the imaginary part. This came last year, final exam, where they just asked you to simplify the complex number, where you need to have your answer in form of a plus bi. So in this case, a is 36 and b is bi is 8, or you can say b is 8i. As simple as that. Any question? Do you have questions? For example, here, let me give you an example of we have got tutorial sheet question 11, question 11a. So question 11a from the tutorial sheet, the question is saying express each of the following in form of a plus ib, which is the same as bi, where a and b are real numbers. Okay, so now we have got part a, which is they have given us 3 plus 2i. Then we have this. Then we also have 2 minus 5i. So they want us to express this in form of a plus bi, meaning that we need to have the real part and the imaginary part. Okay, remember this is the multiplication of complex numbers. We said if you want you can do it direct to say 3 times 2 and then 3 times that one, but sometimes you might make a mistake. So I advise you to simplify this step by step, where you say you are going to have 3 open brackets, then you write everything here, which is going to be 2 minus 5i, then you write again plus 2i, then you have 2 minus 5i. Before we continue, do you have questions? Do you have questions? Do we have questions? Hello? We continue? Okay, so from here we can see that we are going to have 3 times 3 is going to be 6. Isn't it the same question which I gave you? It's different, right? Okay. So what are we going to have? 3 times, we are going to have 3 times 2, which is going to be 6, minus. Next, we are going to have 3 times 5, which is going to be 15i, plus 2. No, no, no. It's going to be 2 times 2. It's going to be plus what? Plus 4i, minus, because this is positive, so it's going to be negative. 2i times that one, we are going to get a 10i squared. So remember that I squared is negative 1. So where there's I squared, we are going to put negative 1. But since we know that I is the square root of negative 1, so this is still imaginary. We can't replace I with the square root of negative 1. Okay? This is the same as if you have got I to the power 3. This is going to give you negative I. Okay? So where you see I, and in most cases you are going to see that I, you are going to be having I squared. You are going to be having I independent and I squared, because they want the answer to be in A plus BI. So we can't replace I with the square root of negative 1, because we want our answer to be in form of A plus BI. We want I to exist. So if I replace I with the square root of negative 1, meaning I is not going to exist. You understand, right? Does that make sense? So we continue from there. We know that where there is I squared, we are going to replace with what? Negative 1. So we are going to say that 6, negative 15 plus 4, this is going to give us negative what? Negative 13. No, no, negative 11. Negative 11i. Okay? Then I'm going to have 10. Where there's I squared, I'm going to put negative 1. So this is going now to give me 6 minus 11i, then plus 10. So 6 plus 10 is going to give us 16. So we're going to have 16 minus 11i. So as we can see, we have got the answer in form of A plus BI. Our A is 16 and our BI is 11i. As simple as that. Yes, Ruthie. Exactly. Exactly. Yes, yes. This part, yes, yes. This part here has got no any mark. But I'm just advising you in case where if you just go direct, sometimes you can make a mistake. But this part here has got no any mark. It is the same as completing square method. There is that part where, for example, you find that the product and the sum, maybe you find that the sum is -1, the product is 2. It is just the same as just going direct without you replacing these. And I'm going to teach you that method when you start functions. So even when you start function, there are some stages where they don't give marks. I'll be able to tell you to say this, but it's necessary you can put it for the sake of you not missing a point. But that part there has got no end mark. Even if you go direct, you're going to be awarded full marks. So that is multiplication of complex numbers. We have done addition because when I say addition is the same as subtraction. We can say addition and subtraction of complex numbers. And then we have talked over multiplication of complex numbers. Okay? Now we can talk of division of complex numbers. Okay? I can also give you another question from here where we say, let me give you a question. You should be taking note of these questions. Um, let's say we have 2 minus 3i, and then I have this. Go ahead and solve this question. Now, your answer is supposed to be in form of a plus bi. You can take a screenshot. Does that make sense? We continue. Are you done taking the screenshot? Are you done? Okay. Okay, so now let's talk about I want us to talk about, before we do, I need to introduce division of complex numbers, but before we do that, let's talk about the conjugate numbers. What do you mean by the word conjugate? What does it mean when you say conjugate? Hmm? Yes, please. I've not gotten your explanation. You can come again. What do you understand by conjugate numbers? If we say conjugate, what does it mean? You are Ruth, right? Okay. Mhm. Okay, I've gotten. Yes, I've gotten your point. Um, now, yes, yes, please. Okay, just a minute before you continue, sir. Be- yes, I get your point. Before you continue, you were saying that it is the interchanging of the sign of the denominator. Okay, so now if you talk of the denominator, now if I give you 2 plus 4i, what is the conjugate of this? There is no denominator here. So your explanation, I've gotten your explanation, but your explanation is just limited to a scenario where you have got a denominator. Hmm. 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 That is the conjugate of the denominator, not so. So you have not defined actually. You are just giving examples. Anyone who can define a conjugate. If someone asks you define a conjugate, what can you say? Conjugate numbers. You get the real part. You are saying this is the number. When you multiply itself, you are going to get a real part. Okay, that is making sense. Another definition. Okay, it's making sense somehow. Now, in simple terms, you can define a conjugate number to say this is the number where you have got the real part and the imaginary part is not going to change. The only thing which is going to change is the sign. You get my point, right? Again, that other point where the guy said when you multiply this, you are going to get a real part. You multiply this by itself, you are going to get a real part. Yeah, that's true. If you multiply a conjugate by its original, you are going to get a real part. That is very, very true. Okay. Now, if I give you 2 plus 5i, what is the conjugate of this? Hmm? 2 minus 5i. 2 minus 5i. Okay. Perfect. Now, the sign changes to the part where there is imaginary and not the real part. You get my point, right? The only sign which is going to change is where there is what? The imaginary part and not the real part. So for example, here we have 2 plus 5i. The conjugate of this is 2 minus 5i. As simple as that. Okay? What if I give you 3i plus 2? What is the conjugate of this? Negative 3i plus 2. Does this make sense? Does this make sense? Yes. You have got a question or you want to contribute? Yes. We can get you. You have been given 3. Uh-huh. Yes. Yes, I can get you. Yes, we are getting you blessings. Hmm. Okay. Yes, it is just the same thing. Yes, it's just the same thing. Even if I change this one to yes, you can put it anywhere. It's just the same thing because you're going to end up getting the same answer. But it is, yes, it is important to put it in this form, because since we are saying that it is always in form of a plus bi, meaning that the real part has to start first, then followed by the imaginary part. So you can start with the real part and then you write the what in the imaginary part, which is just okay with that. Okay. Now, let's say we are dividing these two things, since now we have talked about the conjugate. So let's say we have 3 dividing the complex numbers. Now, I've introduced dividing the complex numbers because we have now introduced the concept of conjugate. So if I have this, I'm trying to simplify this. What I have to do is, they want me to find the answer in form of a plus bi. What I have to do is, I have just to conjugate the denominator. As simple as that. So what I'm going to do now, guys, here is going to be both the numerator and denominator. I'm going to multiply both sides with 4 plus 3i. Even here 4 plus 3i. Now there is a simple way on how you can simplify this. Okay. Now we are saying that if I multiply the part which I am having with its conjugate, what I'm going to end up getting, guys, is it is the same as get the one which is having negative. I want to show you the shortcut, and then I'm going to show you again the long cut. So you're going to choose which one to go with. For example, here you are going to say 4 times 4, 4 times 3, again negative 3 times 4, negative 3 times 3, which is just the same as get the part which is having negative and square it. So if I square this is going to be 4 squared minus, this is going to be now 3i, then I square it, which is going to be 16 minus 9i squared. And then I'm going to end up getting this. Then I'm going to end up getting this, which is going to be what? 25, right? Down there. Instead of me saying 4 times 4, 4 times 3, negative 3 times 4, negative 3 times positive 3i, I'm going to end up having this. So you get the part which is having negative and then square it. That will be your final answer. But if you feel like you are not comfortable with that, you can just do direct now. So just a minute before so down there we are going to find a 25. So let's go ahead and prove this. So we're going to start now. 3 times 4, I'm doing this times this. Let me use different color. I'm doing this times this, which is giving me what? A 12. Then 3 times 3i, I'm going to end up getting what? Plus, what are we going to get? We're going to get plus 9i. I'll go to the next one, which is 2i times 4, which is going to give us what? It's going to give us plus 80i. Okay. Next, 2i times 3i, I'm going to end up getting what? Plus 6i squared. Then I'm going to do this. Down here, I'm going to say that 4 times 4, I'm going to end up getting a 16. So I'm going to have a 16. Then again, 4 times 3, I'm going to end up getting a what? I'm going to end up getting a 12. Next, also it's going to be 12i. Next, I'm going to say that negative 3 times 4 is going to be what? It's going to be negative 12i. Next, I'm going to say negative 3i times 3i is going to give me 9i, negative 9i squared. So as we can see, these two, they are going to cancel because it's 12 minus 12 is going to be 0. On top there, we are going to end up having a 12 plus 9 plus 8 is going to be a 17i. Then it's going to be plus 6, and then I have I squared. Where there's I squared is 1. Then I'm going to divide this by a 16 minus 9 I squared is negative 1. So this is going to, I'm going to end up having this. I'm going to end up having on top there, I'm going to have a 12 plus a 17i, then minus a 6 divided by 16. Negative is going to be plus 9. And for sure, I told you that down there we are going to end up getting a 25. Have you seen a 25? So 12 minus 6 is going to be a 6 plus 17i over a 25. Now, they want our answer to be in a form of a plus bi. So what you have to do is you have just to separate this, and your final answer is going to be 6 divided by 25 plus 17. You are going to say 17 over 25, then you say I, meaning this is a and this is b. Does that make sense, guys? Yes. Do you have questions? If you have anyone having questions, please ask. Yes, please. Yes. You mean if you have, okay, you can give me an example. Hmm. Okay. Okay. For example, yes, I've gotten your question. For example, we have, let's say we have this. You mean if we have something like 3 plus 2i, and then you have 4 plus 3i, not so? Yes. So the conjugate of this, we know that we are going to end up having a 4 minus 3i divided by 4 minus 3i. So you get the part which is having negative always. So the part which is having negative here is this part. So you square this one. So it's going to be a 4 squared minus 3i, then you square it. So it's going to be a 4 squared minus a 4, which is going to be 16, minus that is going to be 9, then I squared. It's going to be the same. So you get the part which is having negative always. You square the part which is having negative. So we're remaining with one part, but since the time is not with us, I think for today we can end here. But before we finish, allow me to give you a question, and then you'll be able to solve, and then you'll be able to send the answer at the same time. So let's have this. Yes, please. Yes, please. In the group. So I want you to give me the answer of this question. This question I've just gotten it from the tutorial sheet. So you can take a screenshot and then send me the answer. Okay? So the answer is supposed to express this in form of a plus bi. And remember, when you come up with the conclusion, remember you need to have a on its own and b on its own. For example, in that case we had, for example, let's say you find that 2 plus maybe 7i, then divided by maybe 5. This is supposed to be splitted into 2 over 5 plus 7 over 5, then you put I. So that you show that this is a and then this is bi. As simple as that. I get your point. But now I forgot one thing. I think you saw something. I posted something in the group to say. I think tomorrow that will be the last free classes, the trial, meaning Monday. Only those who have paid, they will be able to access the classes. So we have got what we call Moodle platform. We have got the Moodle platform for Transcended Institute. I sent a link in the group to say you should create an account. Now, once you pay, we have got courses there. Then you are going to be enrolled there. So the recorded classes and the class link, we post them there. So once it's time for classes, we just tell students to say join the class. Then you log in on Moodle, then you'll be able to see the link and then you join the class. Okay? So we are using Moodle platform. So once you miss the class, what you have to understand is that you are going to find the recorded classes on Moodle. So for example, this class, after maybe 30 minutes, I'll be able to upload. But this one, since it's free, I'm going to post it in the group, and then I'm going to post again on Moodle. So those who are who are already registered, you'll be able to access this recorded class on Moodle, unless you have got some questions. But we end there. Yes, please. Yeah. So for you to access private videos, you are supposed to be enrolled on Moodle. There are some videos which you cannot access on YouTube. Even if you search, you can't find them. But only if you are enrolled, that's when you can do it. You can access those videos. That's how it is. Mhm. Not automatically. You are going to see the link on Moodle. So you are going to be following the Moodle. The Moodle is going to be guiding you. But if you search right now, if you search on if you search on YouTube, for example, I can give you an example of practice question, the advanced question for maybe vectors. You can't find them for physics. You can't find them on YouTube. But if you pay, the moment when you pay, you'll be able to access them. You get my point, eh? So the reason why we are doing it online is just like for the sake of a lot of students, they don't stay in school. Number one. So since they don't stay in school, so we decided to be conducting online tuitions. Because if we tell you to come in campus, if you are staying in Kalingalinga, Handsworth, Kalundu, it's not going to be possible for you to come. Okay? Then at the same time, what if you are busy? For example, today you have missed the class, meaning you not be able to access the class. So for the sake of recording, and for those who are not staying in school, that's the reason why we are doing it online. Okay? But when it comes for the test, most of the times we give it physical. When maybe you are writing a test for transcended. Okay, we end there. See you at 20.